Hi, today I'm going to show you how to set up and use Memory Xplorer. Memory Xplorer is our new EEPROM evaluation platform, which combines a GUI with USB-based evaluation kits for quickly testing and programming EEPROM devices of your choice. You can download the software by visiting the URL in the description and scrolling to the bottom of the page. You'll notice the GUI can be used with any of these three kits, one for I2C EEPROM, one for SPI, and one for our single-wire devices. Download and install the GUI from the bottom of the page. Once you've downloaded the file, double-click on it to run the executable. Installation is fast and easy. Before we get the software running, let's get the hardware set up. The kit ships with samples of 5 different devices. If you'd like to try a different device, you can order free samples from Microchip Direct. Just make sure you select the 8-lead SoIC package. For example, here I'm looking at our brand new 24CS256 I2C EEPROM in an 8-lead SoIC package. Ensure you're ordering the tube type packing media. Insert your EEPROM into the daughter board. Tweezers will help with this since the devices are small. Once the device is inserted into the daughter board, plug the daughter board into the baseboard and plug into your computer. The GUI should immediately recognize the kit. Sometimes you will need to update the baseboard firmware, as our applications team is constantly improving the software. Just follow the on-screen prompts to guide you through it. Once the GUI recognizes the kit, it is ready to use. First, tell it which device you are using by searching in the drop-down menu or by scrolling down and clicking on it. In this case, I'm using the 24CS512. You'll notice certain parts have an icon next to them indicating extra features they have, such as MAC address, unique ID, or enhanced software write protection. Even with no USB kit inserted, you can click on a part to bring up datasheet info, go to the product page, or click on the Buy Samples button, which will take you to Microchip Direct. Anyway, back to our current setup. With the device selected, the software is ready. Click the Start button to read the memory. Once the data is read back, it will be displayed in the center of the screen in the memory array viewer. You can see a bunch of random data from when I last used it. Now we can edit and overwrite the data. You can select any range and fill with different patterns. For example, I will fill this selection with random data. You can also type in data manually. Use the Tab key to move to the next byte. With our changes, the memory array viewer is now acting as a staging area, showing what the data will be if we do decide to write the memory. We have not written our changes to the actual device yet, so let's do this. The EEPROM is now written. We can also fill our devices with data from a hex file. This is particularly useful if you finish designing your electronics product and need to create rapid prototypes for your customers. You can now easily program your EEPROM with the data you need and solder these onto your prototype boards without needing to pay for a programming service. Within the memory array viewer, we can also change the encoding to display data in different formats depending on the encoding of your data. Aside from editing and reading the memory array, we can also vary the voltage and clock frequency of the device. We can also open the pin manager to set the write protect pin. Setting this prevents further updates to the memory array, as can be seen when we attempt to write changes to the array. The changes did not take. Some parts have additional features, which may be viewed and changed in the GUI. For example, on this part, we have a configuration register, a security register, and we also have manufacturer identification and a serial number. Finally, if you have questions or need support, you can go up to this help menu and view the user guide online or contact support directly. We've now shown most of the features of the tool. Some of the most important features, such as the ability to load a hex file, loading data patterns, and changing register settings, are easy to perform, and we hope you find these useful. Development and evaluation tools for EEPROM and other types of memory are either non-existent, device-specific, or outdated. That's why we created this tool, to help you select and experiment with our wide selection of memory devices. We hope you find it useful in your prototyping endeavors.